All right, we've now learnt to factorize and we've learnt to solve, and we're basically now going, well, what can we do with this? So this is applications of quadratics. The area of the parallelogram is 22 centimeters squared, so we're told that. We're asked to find its length and perpendicular height, and it gives us a hint: use the equation below to solve the problem. So area is equal to the perpendicular height times the length. So this one here is our perpendicular height, and this is our length. So y is perpendicular height, y plus 9 is length. So we're going to straight substitute that in to a formula. So a is equal to y times y plus 9, which is equal to 22. Now, whenever I try to do any kind of null factor or solving, and I do want to solve, I want to know what y equals. I can't do that unless I've got everything on one side of the equation. So I'm going to expand this bracket and then minus 22 from both sides. And this is going to give me y squared plus 9y and minus 22, and now it's equal to 0. So we're now in the format that we can use null factor. Well, that we can factorize, so we can use null factor. So two numbers that multiply to give negative 22 and add to give 9. So 11 and negative 2 work. And then I can write that in my normal brackets. So this is y plus 11 and y minus 2. At this point, I'm up to null factor, and I'm going to get out two results here. So I get out y is going to be equal to negative 11, and I also get out y is equal to 2. Now you need to think about these results in practical situations because they don't always work. So y is a length, it's the height. You can't have a negative length for this. Something has to exist. So this y equals negative 11, we can actually just get rid of. It's not a reasonable result, so we cross it out, which leaves us y equals 2. So the length is going to be 2 plus 9, so 11 centimeters. And then the height is given to us as 2 centimeters. So we'd box those two. Example 2 gets us to determine the lengths of all three sides of this right angle triangle. So we don't have all the information, but we do have a way to relate the sides of a right angle triangle, and that's your Pythagoras' theorem. So I can say that c squared is equal to a squared plus b squared, and then I can substitute in those side lengths. So 3n minus 2 squared is equal to n squared plus 2n plus 2 squared. You are going to have to expand all of that and simplify it. I'm just going to use the calculator, but yeah, you can use a distributive property and expand it. But using the expand function, our calculator will solve us some time. So we get out 9n squared minus 12n plus 4 is equal to 5n squared plus 8n plus 4. And I need to move everything to one side of the equation. So I'm going to minus the right-hand side across. That's giving me 4n squared minus 20n, and my 4's actually just go away. So I'm going to factorize just by pulling out a common term, and my common term is 4n, leaving me with n minus 5. This works for the null factor law. So it's not our normal null factor law with two brackets, but this 4n just works like a bracket. So 4n equals 0, and n minus 5 equals 0. And then we just need to solve for n. So n is going to equal 0 or n equals 5. Now again, we can get rid of a result because you need to look at the reasonableness of the answer. Is the answer reasonable? Having a side length on a triangle of 0, i.e. this length here of 0, doesn't make sense. There's no triangle if the side length is 0. So the answer n equals 5 must be the only answer you've got. So write it down, put some units to it, and then actually go back to the question and see what is the question asking. The question says to determine the lengths of all three sides, not what does n equal, but the actual side lengths. So substitute it into 3n minus 2 and 2n plus 2, and you get out 12 centimeters and 13 centimeters to go along with our 5 centimeter for n. Example 3 is looking at a ball and the relationship between the displacement, initial velocity, acceleration, and the time. I'm highlighting them all in different colors, and I'll continue to do this a little bit further down. So we're asked to determine the time or times at which the body reaches a displacement of 20 meters. And the displacement, they're talking about the distance from the starting point. We are told that the initial velocity is 7 meters per second and that its acceleration is at 6 meters per second squared. So I've just color coded everything. So accelerated is orange, and that's the same up here. Blue is time, purple is my initial velocity, and then my displacement's in green. And I'm going to substitute in the appropriate thing. So I can substitute in 27 and 6. Blue is what I'm trying to find, so I'll deal with blue separately in a moment. So I get 20 is equal to 7t plus 1/2. My a value is 6, so 6 times 2 squared. Now, just like normal, I'm going to simplify this a little bit and then rearrange it. So a half times 6 is just 3, so 20 equals 7t plus 3t squared, and move the 20 across to give myself a normal quadratic formula. I can then use the AC method and factorize that. I'm actually just doing that on my calculator. So I get on my calculator that factorizes to t plus 4 and 3t minus 5. So that's my factorized quadratic equation. And now I null factor it. So when I null factor it, t plus 4 is equal to 0 and 3t minus 5 is equal to 0 to give me the results of t equals -4 and t equals 5 on 3. Now I can get rid of that -4 result because for the time of this, or time in this sort of question, starts at 0 and gets positive. We're not looking at a negative time, so we're only looking at the positive answer. So 5 on 3 is our solution, and this is in seconds. So I should have actually had, I believe it's in seconds. Having a quick read, determine the time or times at which, no, so the question doesn't say whether or not. Oh, it does. So initial velocity is meters per second and acceleration is 6 meters per second squared. So I do actually have a units, and that is seconds for this question. So you should have that in there.